Okay, so does anyone recognize this? Matt, wow.
It looks upside down.
Wow, that's really impressive. You got that.
I've read Dan Brown books.
Okay. So yeah, so this is from Dante's Inferno, the 9 levels of hell. And the reason I open with it is because we like to talk about hell a lot as developers, right? So we have dependency hell, we have like build file hell, and there's another kind of hell that actually was mentioned during the last talk, and it looks like this. Now you're not supposed to understand this, that's why it's hell, right? So don't squint. But this is actually the image that shows up if you Google this hell. So does anybody know what this hell is?
Callback hell.
This is callback hell, yes, very good. It's also known as the Pyramid of Doom because of all of the curly braces, right? You're making kind of this pyramid thing. Okay, so that's callback hell. So I'm going to give an example of this on Android. And the example is from the Google I/O app. This is actually last year's Google I/O app. They haven't released this year's as far as I know. So let's just look at this little piece of functionality here. You're on this Explore screen where you can look at different sessions. And you can search the sessions that are Google I/O. You type in information, see how it's kind of live updating this kind of autocomplete or search suggestion list. So that's the piece of functionality I want to look at. Let's look at how that kind of leads to a callback hell. So here's your code for your search view. Don't get too overwhelmed. Basically, you just have a search view, and you have this query text listener. It's listening for changes to that little search view that you saw in the video. And once there's a change in the query text, it executes the search for method. The search for method then sends up some information to analytics, does a bunch of stuff. But the thing you really need to focus on is that it restarts a loader, right? And then we're passing in this as a callback to the loader. So now first we called back from the query text view. Now we're calling back from the loader. And once that loader gets called back, then we have this onload finished, and we can swap out the cursor data and actually update the UI, right? So this is, it's not terrible callback hell, right? There's really just 2 levels here. But, we see this sort of thing all the time, right? This isn't crazy. And what I want to suggest is, and I think this is plausible, when you find yourself in like a developer hell, oftentimes the cause of that is that you're missing an abstraction. And when because you're missing that abstraction, like you're having to deal with a lot of low-level weirdness, and like it just gets really hard to manage. And so we're missing an abstraction. That's why sometimes Android development's hard. That's why we wind up in callback hell. Not just for Android development, but for anybody. JavaScript developers, people who are doing Node, for example. I don't know how anybody does Node development without reactive extensions, because it's just callback hell. Like that's actually what that slide was that you saw was Node development. So the abstraction that we're missing is the reactive extension observable. And what an observable is, and this is really hard to say it in just 3 words, but it's a declaratively composable sequence. Right? I don't expect that to mean anything to you yet, but it will by the time we're done with 134 slides. So what we're going to do is we're just going to kind of break this down. We're going to look at what it means to say that something's declaratively composable. We're going to look at what I'm talking about when I talk about a sequence, and we're going to look at observables in action. Okay? So this is the part where I warn you. So who knows who Dan Liu is? Dan Liu? Yes? Okay, good. Some people do. So Android developer at Trello, Google developer expert. And this is what he says about RxJava, which is just the Java implementation of reactive extensions. He says, I was pretty much dragged into RxJava by my coworkers. RxJava was a lot like Git. When I first learned Git, I didn't really learn it. I just spent 3 weeks being mad at it. And then something clicked, and I was like, oh, I get it, and this is amazing, and I love it. And the same thing happened with RxJava. So we're on like a hard path here for the next couple of minutes, like trying to grok this stuff. But the reason I bring this up is because I just want to, I guess, reassure you that it's worth it. Like there's some amazing stuff. Now, the reason that I think it's so hard to grok RxJava is actually you're dealing with abstraction in 2 different dimensions. So on the one hand, you have abstraction in terms of how data is represented in memory, and that's this x-axis here. And that might not mean a lot, but just give me a second. And then on the other hand, this other dimension is abstraction in terms of how you're composing sequences. And so we're familiar with Java arrays, which is like kind of the basic shit right on this graph. Like there's not a whole lot of abstraction. That's why we're in callback help, right? But we're familiar with this, and we're also familiar with Java's iterable, right? We're less familiar with Kotlin's iterable or with Java 8's streams. And it turns out that these are kind of a nice stepping stone to really understanding what reactive extensions is doing. And so RxJava's observable is kind of in this upper right, or upper left, I guess for you guys, upper left corner here in terms of the abstraction. And what sucks is that we try and go from Java's array, and then we have kind of shaky like understanding of the iterable. We just try and go straight to the observable, and it's really hard. So what I'm going to try and do to kind of help us out is point out like other abstractions that we might not know about, and just kind of explain those things. And that way, by the time we get to this observable, hopefully it makes sense. So that's kind of the plan for dealing with this being kind of a complicated thing. Now, a lot of people say that this is hard to learn, but well, okay. Does everybody know what this is?
Is that over the cave?
Yes. Wow, you guys are awesome. Okay, so this is the allegory of the cave, and I'm gonna put you on the spot. Do you know kind of what this stuff means? Like how it fits into the allegory?
The people in the furthest on the left.
Right.
This is like all the reality that they've seen.
Right.
Because they're scared to go outside for some reason that I forget now.
Right. They're actually like prisoners. They're bound there.
Right.
Right. So keep going.
And then they've been told that going outside is bad.
Yeah. Okay. Okay. Good. All right. So I'll pick it up here. So okay. There are these people that are in a cave, and they're bound, and all they can see are shadows on the wall. So you can see that there are these objects here, and then there's a fire, and the sun comes, or whatever, the fire produces light, and then there are these shadows on the wall. And their heads are fastened. This is kind of a far-fetched thing, but the allegory is like 2,000 years old, so give me a break. But their heads are fastened to this kind of cave wall, so all they can see is the shadows, right? And what Plato says, this is Plato's allegory, he says, if there was somebody in this condition, they would think that the shadows were reality, because that's all they've ever known, right? And they would actually, if they ever got up and left, they would turn around and they would look towards the light, and it would hurt. They would be like, this is terrible, like this is bullshit, like I want to go back to my shadows, that's the real thing, like what is this light and all this nonsense? And they would kind of go towards that, and then when they got up out of the cave, they'd be like, what is all this bullshit? Like this isn't real, right? Like my whole life, it would be like, I don't even know, I was going to compare it to the Matrix, but that's not a good analogy. Like if your whole life is, you're just used to shadows, and that's reality for you, and then all of a sudden you see everything, right? That's going to be jarring, and you're going to think it's not real. But what's interesting is that, like, okay, the shadows are less real than like the reality that the person's experiencing after they got out of the cave. So I want to make an analogy here that the same thing is going to happen when you understand what this phrase is. So on the one hand, like it's going to seem really hard or whatever, but when we get to the end of this, you're going to be like, okay, this is the most natural thing in the world. This is the real thing. And I've just been dealing with shadows and bullshit for like until now. It's going to change the way you think. It's going to change the way you think. Okay, so all right, so let's talk about declaratively composable things, right? And this is, just to be clear, we're kind of along this y-axis of abstraction. So let's see. It seems like okay. So we're going to stop off in JavaScript land. Don't get too mad, okay? I know JavaScript is not people's favorite language, but we're going to stop off in JavaScript land because it's a helpful stepping stone to getting where we want to go. So we're stopping off in JavaScript land, and that'll get us to understand what like a declaratively composable array is. All right. So the easiest way to understand this is to think about what an imperatively composable array is, right? And that's just Java's array. So this is we're familiar with this. So let's look at what this would look like. So we have an array of countries. Countries have names and populations. So there's 300 million people in the United States, 36 million in Canada, 127 million in Mexico. And if we wanted to get the populations from that array of countries, then here's what we would do. We would write this code, and this is Java code. Hold on a second. Okay, JavaScript, sorry. A couple of rogue slides. So here's our JavaScript array. Oh my goodness, my slides are out of order. Okay, I said we were going to stop off in JavaScript land, but just pretend I didn't say that. So, because we're going to get there eventually, but let's just look at it in Java. So this is what we're doing in Java. We have our array of countries, and then we're going to create a new array of doubles, and then we're going to loop through the array of countries and just swap out the populations with in this array with the populations of the countries, right? This is a pretty simple piece of code. This is all imperative, right? We're kind of step by step saying what we want to do, and there's not really like a whole lot of abstraction going on here. So now let's look at. So that's kind of an imperative like composition of a new array. We had an array of countries, now we have an array of populations, and we did that imperatively. So let's look at how we would do this declaratively. So, and this is now we're getting back into JavaScript land. So here's our array of countries, and then here's how we would do this in JavaScript. So it's just really, really simple. So who's familiar with map? People know about this? Oh yes, this is awesome. Okay, great. I won't spend a lot of time on this then. I'll spend 0 time on this. So I'll just say that when you use map, right, it's a declarative thing. You're just saying what you want. I have countries, map them to populations. And I'm not looping over things. I'm not like giving a step-by-step list of things to be done. I'm not creating a new array and then populating it. It's declarative, right? Now, since you guys are all familiar with map, you're like, well, yeah, okay, but it's functional programming, right? And it's like, yeah, that's true, but those are orthogonal concepts. So something can be functional and declarative. And what I want us to focus on is that this is a declarative way of composing a new array. Okay, so that's JavaScript. I was going to go over how map works, but if everybody gets it, then we don't need to. Okay, so there are a bunch of these, right? There's map, there's filter, there's reduce. And it's really neat. You can do stuff with them. Since you guys are familiar with this, I'm going to speed up a little bit. So let's say you just wanted to get the population of North American countries excluding the United States. If you did this imperatively, there could be kind of a significant amount of code here, right? But if we do this declaratively, then we can just filter out the United States out of the list of countries, right? Because we hate the United States. Maybe we don't like Trump got elected or something like that. I don't know. And then we can map from countries to the population. So now we have an array of populations. And then we can reduce that array down to a single total that collects everything, right? So this is all declarative. There's not like, step-by-step things where I'm looping over the array, creating new arrays and all this stuff. I'm just saying what I want. Filter out the United States, I don't like it. Map to populations, I'm interested in that. And total it, right? Declarative. So the result is going to be something like this. We filter out the 300 million and then add up everything else. Okay, so we know what a declaratively composable array is, right? So that gets us here. Great. Okay, so if we take these kind of ways of composing arrays, map, filter, reduce, and then we try and use them with a linked list, then there are explosions. And the reason there are explosions is, specifically in JavaScript, is because arrays are stored in memory in a particular way, right? It's a contiguous block of memory. And so we have to worry about how is the sequence stored in memory. Now, this question actually brings us along the x-axis of abstraction, and we move from Java's array to Java's iterable, where we get to stop caring about how the data is represented in memory. So let's just look at an example of that real quick. So we have an array, let's say, and then let's say we also have a linked list, but really we don't really care about the details of how those things are represented in memory, right? So with an array, we have a contiguous block of memory. With a linked list, we have these nodes and kind of like linking to the next thing. So what we want to do is We want to have an iterable, just something that abstracts away from the differences in how that data is represented in memory. So let's look at this again with our countries. We have an array of countries, and we're not going to try and do anything fancy. Let's just say we loop over them. So this is how we would do this, like in Java 5 or something, right? We would just get the length of the countries and then get the indice of the array. But notice that this isn't going to work with a linked list. It's explosions, right? We can't do this kind of same piece of code. However, this colon syntax, you guys probably know this. This uses iterables. Do people know this? People are familiar with this, right? This for each. It works. Oh,
I knew that.
you knew that?
It was
Awesome.
in the back of my mind. I kind of forgot for a second.
Yeah.
You just reminded me.
So the reason this works is because there's an iterable abstraction, and basically the array kind of gets turned into this iterable, and then it can loop through everything. And that way, basically, you can use this for each syntax on arrays or linked lists. It doesn't matter. Just completely abstract over how the data is represented in memory. So it could be an array, a linked list. It could be. It's just an iterable. Like that's all we care about. So we don't have to care about how the sequence is stored in memory. And so that again, that gets us kind of on this x-axis here. We're abstracting along the memory dimension. Now, and we've already talked about how we can kind of declaratively compose arrays. Now, since we don't actually care about how the sequences are stored in memory, when we actually introduce the iterable abstraction, we can actually get the same kind of declarative composition, those map reduce, those higher order functions. We can get those and apply them to iterables in general instead of just arrays. And that's, if you look at Kotlin's iterable or streams, Java 8 streams, that's really what's happening there. So that gets us to a declaratively composable iterable. Okay, so really, let's run through that, like what that looks like in Kotlin. So let's say you have your function, you're trying to just get populations from countries. We can do this in Kotlin really easily. We take in an iterable, and then we can just call map on it and get the population, right? In a declarative way. And it's on an iterable, it's not just an array. So we don't care. We can do it with linked lists, we can do it with sets, we can do it with, it doesn't matter. We've abstracted over that. We already know how map works, so, is it helpful to go through this? Like how, this is like how map actually works. Should we look at this? Yeah, okay, let's look at this real quick. So this is the map function in Kotlin. It's an extension function, interestingly. And it's an extension function on iterable. And basically what's happening is this, for item in this, and this is the iterable, because it's an extension function. And this is actually using an iterator to do this, right? So this is kind of meta, but we're just going through each of the items in the list, and then we have this, this destination array right here, and we're adding a new item to the array by calling the transform function that's passed in, right? So that's what's happening there. And so yeah, we can do the same thing that we did in JavaScript with Kotlin, except for we can do it with an iterable, so it's more abstract, right? We can do it with any kind of collection. And so that's what we see here. Again, we're filtering out the United States, we don't like it. We're mapping to populations, we're reducing to get the total, it gets us this thing. Okay, so that's declaratively composable iterables. So we're here. And so now we have to kind of make this last step up here to observable. And again, like this is, all right, we're on the brink, all right? We're getting like close to the, the surface here, and you're gonna see things differently here in a second. But let's take a quick break. Funny story. I worked at Disney for a while, and one day somebody was doing something on the network where they were basically accidentally DDoSing Google, like through their API or something. So Google like shut everybody down like on our network. They're like, you can't hit any, like everything's done, And so I learned this, and I was like, well, how am I supposed to get any work done? Like right, I need Stack Overflow, I need Google to get, like, how am I supposed to do anything at all? And I was serious, okay? I wasn't like screwing around. And somebody was like, well, you could just use Bing. And I was like, oh, right. And I think it's a funny example because like Google just like dominates like my mind in terms of like search engines. There is no other alternative. And again, I want to say the same thing is going to happen once you really grok this declaratively composable sequence, it's going to change the way you think. You will not be able to think without like thinking in terms of RxJava or reactive extensions. And yeah, somebody will say, you can't use this library, and you're like, how am I supposed to freaking program? I don't know. Okay, great. So we've talked about arrays and we've talked about iterables. Now let's talk about sequences. Like what is a sequence? And if you, again, this going back to the allegory of the cave, like if you think about a sequence, like take your computer science hat off, a sequence isn't like an ordinary term. But like if in everyday language, if you hear the word sequence, you're just like, well, it's just like ordered like set of stuff, right? And that's kind of what you think of. And you don't care about like, well, how is it represented in memory? And like, and another thing you don't care about, and this is getting to the second point, is you don't care about whether the data is in memory currently. You don't even think about any of that stuff. You're just like, this is a sequence, this is an abstract thing. So that might not make a ton of sense now, but hopefully it will in a second. So that's a sequence. Let's look at this click listener. Okay, so we're setting a click listener on a button. We do this every day, right? This is nothing crazy. What I want to suggest is that this is actually pretty similar to this. So if you had an array of button clicks and you just looped over it and then called track click, right? These things are very similar. Basically, you have in your mind, you have a sequence of button clicks like that maybe they haven't happened yet. The data isn't in memory yet, but you can imagine like these button clicks as like a sequence of things that haven't happened yet, right? So these two things are actually pretty similar. And let's kind of highlight this even more. I mean, set on click listener could be called for each click. And that's exactly the same thing this is for each, right? That's the name of the syntactic construct. So, okay, instead of having a button, we could say, okay, well, it's a click sequence. And so, yeah, we can imagine this, right? This isn't a big deal. We could imagine there's this sequence of things that haven't happened yet. These events that aren't in memory yet. And we want to do something for each one. And that's what an observable is, right? So this changes, like, we just went from click sequence for each click. We're kind of slinging in, this is like bullshit code, but okay, this is real. Click observable, subscribe. We pass in this consumer, and then we're doing something with the click. All right, so we're getting into observable land here. How we doing? Did I lose anybody? We're good? Okay, great. Oh.
What does subscribe mean?
Yeah, what does subscribe mean? So it kind of means the same thing as, let's go back. So you're setting a click listener. So when you set a click listener, what you're saying is, I'm interested in click events, right? That's why you do that. You're saying, here's this listener, and it should be listening for click events. I'm interested in that. So when you're interested in something, we usually subscribe to it, right? Like we follow people on Twitter, we follow RSS feeds, so that's kind of the same like metaphor here with subscribe. We're subscribing to this click observable, this sequence of clicks. We're interested in them, and they're going to get pushed to us asynchronously. So does that make sense?
Yeah.
Cool. Okay, great. So that's kind of this idea of a sequence. We don't care about whether the data is in memory or the events are in memory or whether they've happened yet. We don't care about exactly how those things are represented. We don't care about any of that. It's just a sequence. Okay. So what does it mean for these things to be declaratively composable? Well, we already know what it means for an iterable to be declaratively composable. We had this map and filter and reduce, and we tried to add a linked list, and then there were explosions, and the reason that happened is because we had to worry about how the sequence was stored in memory, and then we introduced an iterable, and then we stopped caring about that, right? The same thing is going to happen here. We have these kind of declarative ways of composing sequences, map, filter, reduce, and a bunch of others that we'll see in a second. And we try and add like async to that, like something that's asynchronous. And explosions, okay? And the reason that happens is because we have to worry about whether the sequence is currently in memory. Okay, the abstraction that we introduced to stop worrying about that is observable. So we don't worry about that question anymore. So that's that. This next slide seems wrong. Let's go through this. Let's see. Oh yeah, okay. This I'm just going to reiterate this. I guess we have arrays, we have linked lists. We don't really care about how it's represented in memory, so we introduce an iterable. and then maybe we have some other things. And so the sequence or the observable is basically just like another step along kind of this memory dimension of abstraction. Where it's like, not only do I not care about how it's represented in memory, I don't even care if it's in memory right now. I don't even care if the sequence is in memory right now. Okay, so that's a declaratively composable sequence. How are we doing? We're gonna look at like an example of like this in action, but we're following? Great. Hopefully that wasn't boring. You guys seem pretty sharp. You're like, wow, I already know math, and I already know the algorithm of the cave, and Dante's Inferno. So, all right, great. So let's look at this example again, right? So video, great, video's going. Okay, so we're typing in a bunch of stuff, and we're updating the UI with the results to see what the sessions are. So remember how I was saying, like, when you get this stuff, and I've been doing reactive extensions for a little bit. When you get this stuff, you start thinking in terms of sequences. So what I see when I look at this feature is two sequences. The first, I was going to animate these in. Oh well. The first sequence it's the sequence of query strings that are entered in over time. So we saw in the video, first it was K, then it was KE, then it was KEY, right, and so on. So you have that sequence. And then there's another sequence, which is the search results for each of those query strings, right? And these, again, this is all like asynchronous. It's going to happen, but we're not worried about that. Like we're just thinking in terms of these sequences. And then finally, basically, once we have the second sequence, we know that for each result, update the UI. I just think of this as like a for each, at the end here. So let's look at how we would actually kind of implement this using reactive extensions. So here's a piece of code. Now remember the code that I showed you before, all right, where I was like, this is kind of like a little mini callback hell. We get the functionality that I just showed you with this beautiful little thing right here, right? It's just like, and it looks even better with Kotlin. It's awesome. Like it's just, a couple of lines. So what we have is this query text observable, and that is the sequence of query strings that people are entering in asynchronously, right? So we have that. And what we saw the second sequence that we want is the search results. And we get that sequence by applying this operator called flatmap. Now, who's familiar with flatmap? Oh wow, you guys you're the man. Okay, a little bit of familiarity. That's another just kind of declarative way of composing. You've probably used it with like iterables or maybe arrays or whatever. Python has these things, lists, whatever. But this is just a declarative way of composing like a sequence, right? And what's happening here is it's taking each query string and turning it into it's turning it into the search results for that query string. That's what's happening. That's a little bit oversimplified, but let's not hurt ourselves. So that's what's happening there. So when we apply that operator, we wind up with this sequence: results for K, results for KE, results for KEY. That's what we wind up with. Okay, great. So we have that sequence, and then the last step is just this kind of for each thing. And that happens with the subscribe. So the subscribe is just saying, hey, I'm interested in each of these search results. So basically for each of these things, swap out the cursor, and that'll update the UI. So that's what we get there. Now, some of you guys are like, this isn't that impressive. The really awesome part about reactive extensions is it's the extensions part. So what we just went over is like kind of the reactive part of reactive extensions. We introduced this observable, this reactive abstraction for doing kind of reactive programming. And the extensions part is all of the, what they call operators, the ways of doing the declarative composition. So reactive extensions comes with flatmap, it comes with map and filter and reduce, but it also comes with a bunch of other things. So let's look at an example of that. Well, first, let's look at a familiar one. So it comes with filter. So let's say that, so here's the filter line of code. Let's say that we wanted to set up our feature so that we're not querying a database or querying an API endpoint every time somebody types something in. Or let's say they type in like KE, And we're like, they're not going to get anything useful back, right, for the autocomplete there. So we don't actually want that to trigger an API call. So we can do that really easily with just filter, right? We can just apply a filter. We declaratively compose the sequence. And so with filter, this top sequence, K, K-E-Y, K-E-Y-N, it becomes this bottom sequence where we filter out the first three entries. That way we're not hitting the API endpoint for those times. And that's really simple, right? One-liner. Boom, declarative. Like, it's awesome. Okay, maybe you're still not impressed. Okay, let's say we want to set things up so that, actually I'll leave it here. So let's say we want to set things up so that when the user is typing into that search field and they get 3 characters, we still don't want to hammer the API endpoint when they're typing really fast because they're not done typing. So we don't need, like, if it's expensive to make that, like computationally expensive to make that call, then we're going to wait for them to like slow down a little bit so that we can actually make the call and do it, right? So this is, with reactive extensions, this is trivial. It's a one-liner with debounce. Okay, we can declaratively compose the sequence. Now the sequence looks different after we apply this operator. Unfortunately, I don't have this like mapped out, but basically when we apply debounce, what this is going to do is it's going to make it so that if there's less than a 300 millisecond delay between 2 keystrokes, then nothing happens. So, or in other words, there has to be at least a 300 millisecond like delay between keystrokes before it'll actually make the API call. So that way we're not hammering the API endpoint with like a bunch of useless queries. One-liner, okay? There was an older version of Google I/O where they actually tried to implement a debounce imperatively. And I thought about including it, but I was like, oh, this is older. They realized it was shit code and like didn't include it. But it's horrible. I mean, just think for a second, like how that's pretty complicated to implement that imperatively. But you get this declaratively with reactive extensions. Okay, so that's that. Maybe you're still not impressed. Okay, fine. So this actually came up last talk. How do we handle threading with Kotlin? And there's actually a really nice way of handling threading with reactive extensions. And again, it's just a part of this way of like declaratively composing these sequences. So you notice that 2 operators have just been added here, subscribe on and observe on. So when I apply these 2 operators in just 2 lines, what's going to happen here is it's going to do all of the network requests and all of the kind of computationally expensive stuff on a background thread. And then it's going to bring me back onto the main thread for this subscribe call right here. Like this code that gets executed is going to be on the main thread. And you get that in 2 lines. No handlers, async tasks, like any of that. You know, it's boom. That's what you have. And you can make it even shorter, like because you can actually make your own operators and stuff. But then you can kind of again, you're just declaratively like transforming, composing this sequence in a way that it does exactly what you want. So that's that. And that, believe it or not, is 134 slides. But yeah, declaratively composable sequence, reactive extensions, observable. It's awesome. Questions?
So when you can you go to that last slide?
Sure.
Last one,
Yep.
So when you run the filter, then you're filtering for less than a 3-character length query. So
That's right.
So Google starts searching on every character.
Sure.
So you're doing that just because we're not Google, we don't have the resources that they have available.
Well, it has more to do with
Handle that little.
you're a mobile application and users are paying for the data that your application uses, right? Especially in like developing countries, you don't want to just unnecessarily make API calls that aren't actually going to be useful for the user. So I think it has more to do with just like being a mobile application and being kind of sensitive about how much data your application is using. In fact, I believe, to your specific point about like we're not Google, I think that Google does something similar in an older version of the I/O app where they filter out queries that are, smaller, less than a certain thing. Any other questions? Yeah.
Would it be safe to say that debounce is a buffer of some kind?
Yeah, that's that is safe to say. Yeah.
So with that said, what's the difference between debounce and flowable?
Debounce and flowable. Oh snap. Okay, flowable. We might be like thinking of two different kinds of flowable because it turns out that flowable is there's observable and then there's something called flowable, which is a
that's what I'm
specialized.
talking about.
Oh, okay. So flowable.
In reference to debounce.
Oh wow, are you talking about back pressure? You know your shit. Is that what you're bringing up right now?
Yeah, a little.
Okay. So let's back up for a second. So we just talked about observables, right? And in RxJava1, there was just observable. RxJava2 has come out, and now there's all kinds of they call base reactive types. So there's observable, and then there's something called flowable. Now flowable exists because it exists to help you deal with something called back pressure. So let's see if this is a good example of this. Okay, great. So, I should have gotten rid of those exclamation points. Anyway, back pressure happens when an observable sequence is emitting data faster than it can be consumed. So you can imagine like the user's typing really fast, right? And then in the subscribe call down here, maybe we're doing something really expensive. Like instead of just swapping out a cursor, maybe we're like computing the 1000th Fibonacci number and then doing that, right? That's contrived, but you get it. Like in that particular case, the data in the observable sequence would be coming faster than we could process it. And so that produces back pressure. Now, one way of dealing with back pressure is to filter the observable sequence by using a filter operator or maybe a debounce. But there are going to be times where you don't actually want to apply those operators. And in that case, you use the flowable base reactive type. So to answer your question, like what's the difference between the two? Both of them are strategies for dealing with both of them are often, or maybe not often, but both of them can be strategies for dealing with back pressure. But really flowable is kind of exclusively for dealing with back pressure, whereas debounce, in this case, it wasn't about back pressure, it was just about not wasting users' data, right? So we had kind of a different purpose.
Okay.
So I think, does that answer it?
Yeah.
Cool. It's a great question. Yeah.
So the two big, I guess, topics that we were talking about were the concept of kind of imperative thinking and reactive thinking.
Sure.
And making that jump, I think, for at least for me, years ago was also difficult as well.
Right.
It was the first time people with the user interface, right? You're reacting to an interface
Right.
call or reacting to data.
Right.
And so I think, if this is totally foreign to you in terms of reacting to data streams or reacting to data coming to you like this,
Right.
what do you recommend be the stepping stone from thinking imperatively to reactively? Because we have the tools, thinking like iteratively loops and iterations and things.
Right.
But how about in thinking step by step, like you said, and thinking about, well, I'm just going to wait for something to happen?
Yeah, so it's interesting, like the way that I think about, and I should have given another example to illustrate this point, but so I'll say two things. One, observables aren't necessarily asynchronous. So you can create an observable from an iterable, and then it'll just emit the data that's in the iterable synchronously. And so this is also going back to the idea of like a sequence. Like when I think of a sequence, like I'm not thinking about like when it's going to happen necessarily. I'm not thinking about how it's represented. I'm not thinking about any of that. And so when I think about reactive extensions or observables, I'm not even thinking about reactive programming or reacting to something. The way that I'm thinking is, let's go to like an example of, yeah, this is a good example. I'm thinking like this observable, it's just an array of everything that hasn't happened yet. That's really how I think of it. It's just a sequence, or not an array because that's not quite right, but it's kind of like an array of something that hasn't happened yet. And as soon as once you have that, or when I think that way, and then I'm also like kind of familiar with, the other languages where they're doing like for each and map and reduce, like JavaScript or Kotlin. When you're familiar with those things, it kind of falls in place. So, to summarize, sorry, I know that was a long-winded way to answer your question. I think the jump from imperative to reactive, it's not necessarily something that you have to make if you're trying to use reactive extensions. it might be more helpful to just be familiar with kind of these declarative ways of composing, like iterables or arrays or whatever. That's synchronous. Just be familiar with that, and then just tell yourself when you're working with reactive extensions, like this is just a sequence of stuff that hasn't happened yet, you know. And then you don't even have to. It's the same, right? And it's crazy because like I really wish that I gave this example. There, I'll just say it out loud, and hopefully you can follow. So, oftentimes you're working on an app, and you're working against like some API endpoint, and the API endpoint you hit it and it gives you a list of stuff, and then you have to take each element in that list and then make another API endpoint in order to get more data. That's shitty. Sometimes it happens because the people working on the back end don't really want to like give you a better endpoint, right? This has happened to me before. It's happened to people in this room before. And so what you can do at that point is you can create an observable that represents kind of making that initial call. And then when you get that list of data back, you can turn that into an observable. And then use that to make another observable that fetches the data for each of those things. And like when you see the code, it really just like melts the distinction between synchronicity and asynchronicity. And that's something that and maybe I should have said this tonight, but that's another way of thinking. And this is, I should say, this is not a conventional way of thinking about reactive extensions, but it really, I see it as abstracting over synchronicity. You don't care anymore because you use map, reduce, and filter for your synchronous, data sequences or whatever, and you do the same shit for the asynchronous stuff. It's just you think the exact same way. So yeah, that was a really long way of answering the question, but hopefully that was helpful.
No, it was a great exploration.
Okay.
I've also learned that the universe is a series, is an array of events that has yet to.
Yeah.
That's good.
Great. Any other questions? Okay. Well, thank you guys so much. This is fun.